Welcome back to the Explainer. Last time we were hot on the trail of a phantom bug, an infinite loop hiding deep inside our data. We managed to prove it was there, but that left us hanging with one final, really important question.
Right? This was our cliffhanger. We found the trap, but we didn't disarm it. So today, we're going to answer that question, and we're going to finish the job.
Exactly. The chase is over, and now the real work begins. We're moving past just detecting the issue and getting our hands dirty with the solution. All right, let's dive right in.
Now, before we jump straight into the fix, let's quickly revisit the crime scene. Just a quick refresher to make sure we're all on the same page before we make our next move. Remember how our linked list, this nice orderly chain of data, was totally corrupted? Yeah, its last node, instead of having that final stop sign, was actually pointing back to an earlier node. And that's what created this vicious cycle with no way out. To find this trap without getting stuck ourselves, we sent in our two detectives, right? We had the slow pointer, our tortoise, moving one step at a time, and the fast pointer, the hare, leaping 2 steps. And that difference in speed, that was the whole secret.
And boom, collision. That was our smoking gun. The fact that the hare actually lapped the tortoise and they landed on the exact same node, that was all the proof we needed. See, if there were no loop, they would have just never ever met.
So, here's the really crucial thing to remember. We know there's a loop, but that spot where they collided, that's not necessarily where the loop begins. To really fix this thing, we got to find the exact node where it all went wrong. So finding that origin point, that's our next big job. It's like, you're on a roundabout, but where's the exact on-ramp that got you stuck here in the first place? How in the world do we pinpoint that specific node? Well, it turns out there's this really elegant, almost magical strategy for this. It's like a second phase for our investigation. We're going to do another chase, but this time, our detectives are going to be working together, in perfect sync. Okay, so here's what we do. First, we take one of our pointers, let's just use our slow one, the tortoise, and we send him all the way back to the start, right back to the very beginning of our data chain. Meanwhile, the other pointer, it just stays put, right there at the collision point. All right, you with me? One pointer's at the beginning, the other is at the crash site. Now phase 2 begins. We start moving them both forward at the exact same speed, just one node at a time. So no more tortoise and hare. This is more like 2 investigators methodically walking the beat, step for step. And this is where the magic really happens. The exact spot where they meet this second time, that is the start of the loop. It's brilliant, right? I mean, it turns out the math works so that the distance from the head of the list to the loop start is the exact same as the distance from that first collision point to the loop start. So by moving them at the same speed, they are guaranteed to meet right at the source of the problem.
Okay, so we've found it. We've pinpointed the entrance to this data roundabout. Now we can finally move in and dismantle this thing for good. It is time to break the cycle.
So what's our target? Well, here's the trick. It's not the starting node of the loop itself. Nope. We need to find the node right before it, the one that's actually holding that rogue pointer. That's our culprit. And the fix itself? It's so simple, it's beautiful. We find that final node in the proper chain, and we just change its pointer. Instead of letting it point back into the list and create chaos, we redirect it to null. Our universal, the end sign. And just like that, with that one simple change, we're done. The trap is broken. By setting up that proper endpoint again, the infinite loop is just gone. Our data structure is back to being a clean, straight path. Case closed. So that's the theory. But how does this look in practice? Let's take a look at the detective's final report, the code, to see how this whole strategy actually gets put together. So this first function, this is what finds the start of the loop. It's basically our whole 2-phase investigation wrapped up in code. First, you've got the tortoise and hare part to find the collision, and then you've got the second part, that synchronized walk that leads us right to the loop's origin. And then this second piece of logic, this is the part that actually breaks the cycle. Once we have that starting node from our first function, this code goes and finds the node right before it. It traverses the list until it finds the culprit, and then it performs that final critical snip, setting its next pointer to null, and that's what breaks the chain for good. Okay, so we did it. We solved this one specific, kind of nerdy mystery. But so what? Why does mastering this one little data puzzle matter in the grand scheme of things? Well, because this isn't just about fixing one bug. It's about learning a fundamental pattern.
This whole idea of detecting and breaking cycles, it's a super powerful tool for figuring out all kinds of problems in really complex systems, whether you're talking about a frozen app on your phone or totally corrupt data in a database.
I mean, this logic is a total cornerstone of computer science. There's a reason it's a classic technical interview question, you know? It's the same core logic you'd use to untangle messed up database records or to stop network packets from bouncing around in an endless loop. It's a fundamental building block for solving even bigger programming mysteries.
So learning this pattern, it's not just about fixing a linked list. It really teaches you a whole new way of thinking logically about problems. And it kind of makes you wonder, right? What other seemingly impossible, unsolvable problems are out there that are really just a clever algorithm away from being cracked? Thanks for joining me on this explainer.